What's up, guys? We are here on a very special virtual press event with Yamaha. We've got Phil Shea, the product trainer. God, Phil, you've been with Yamaha for decades, man, right?
Yeah, the end of the month will be 37 years.
Holy cow. You know, what is your secret? Because you don't really age that much, man. You look pretty much the same since the day I met you.
Yeah, some days are better than others. Yeah, no, it's been fun. I mean, it's I've done a bunch of different things, so it's like working for 5 or 6 different companies over that career, and the people are great, the company's great, brand's great, and why move?
Yeah. Well, you know, you're good people, Phil. We've had lots of correspondences in the past. I've done lots of videos with you guys.
Yep.
Phil is one of those guys that's in the field. He's had so much experience with install, with training. I mean, you know Yamaha products in and out. I'm really happy that you're here to drop us some knowledge because, man, I'm looking at that new AVENTAGE line and I'm getting all little tinglies because it's making me remember. It's reminiscent of the days of the super receiver almost. You guys are jumping the gauntlet on this line. You're putting a lot of stuff into this that you didn't have in the preceding models.
Yeah, and we'll go through that because there's a reason for that, and this new line it's set for the next 10 years, literally.
Wow.
I mean that's kind of how we build the chassis in the platforms because that's what costs a lot is the layout, the circuit, what controls. Are you going to use a TI chip, Texas Instruments to do all your controls? So that means all your code is written for that one. So you can't be switching it up. So that's why it takes a long time in between like generational changes.
Right.
Because you're rewriting different codes to different languages. That's going to last for a long, long time because that's what chews up a ton of engineering is just making the LEDs go on in the front panel display. If you're using a different platform, it's start from scratch.
So before we get into your presentation, what differentiates, and maybe you'll do this in a presentation, but what differentiates the RXV line from AVENTAGE, which is what we're going to be going over today?
Yeah, it was 11 years ago in 2010. We had 11 AV receivers in our lineup. From very entry level to flagship. They were all RXVs. And that's when people started shopping online and started doing their own shopping and comparison was about that time. Because that was, the internet, we can shop on the internet. That's a cool thing. And so they'd come to our website and they'd look at 11 different receivers and go, I don't know what this feature is, so it must not be important to me. So I'm going to go to this one right here. We did a bunch of surveys and we find that when customers were left to their own devices at that time, especially, they always undersold themselves. They really could have used that feature for their application of the next model up. So what we did is we split our line in half and we totally reworked the upper half. And we always use the Toyota Lexus kind of comparison.
Right.
The bottom line is it's a Toyota, it's reliable, dependable, lasts you forever. It's good product. If you want to go in a little more style, more features, a better experience, then you jump up to the Lexus. So now when we split the line like that, people will go on, okay, well, I'm looking at this right here, and it looks like it matches my needs, but why is this stuff a little more? And then you start investigating the AVENTAGE Advantage, and is that important to me? Is better sound quality important? Is more zones important? Is more power? It gives them a reason to explore the whole line because 11 models from the same brand, that's overwhelming. How would you even start? And so we took 2 years off to develop that original line in 2010, which was really painful. We didn't have a pandemic in between. That's why this was a 3-year process. It was only supposed to be 2. But we didn't have new models for that second year, so it was kind of tough. But we bid it because we knew that the AVENTAGE line was going to be with us for a long time, and it lived up to that. It's lasted us 11 years. Now we're upgrading to the new line, the new platform.
Yeah, I got you. I mean, some of the features on this look incredible. We did a preview article a few weeks ago. I linked it up in the video description down below. If anybody wants to read at their own leisure, you're welcome to do that. But Phil was kind enough to put together this PowerPoint presentation. he actually has their flagship, the RXA 8A. That's a hard one to say, man. I have to tell you.
We'll simplify it. Just call it an A8 and an A6.
A8. And that one retails for what, about $3,000?
$3,000. Yeah, that's $3,000. Yeah.
Okay. So what I'll do now is I'm going to share the screen. You can kind of go over your presentation, and then maybe we can take a break and kind of look at the dissected model of the flagship to show people what's inside and how it differentiates from, you know, what you've done in the past and maybe even some other competitors as well.
Cool. So I should be up.
So what are we looking at? What is that image of? Like it's a blown up image of something, right?
We're not exactly sure. We think
I thought it was some punk rocker's hair or something.
It kind of looks like that. This is a 10-foot by 8-foot image, and this is a crop. So you'll see these color schemes all throughout our websites,
right,
all internationally. And depending on the product, we'll find a different crop. We'll crop into a darker portion of it, or it's just to upgrade the look rather than the black screen with the Yamaha logo on it.
Right.
You know, this is 2021, so I mean, color is free. So we decided to throw some color and everything. So this is what we do. All right, so let's jump into this. Okay, overall, this is kind of what we kind of talked about the new platform. I'm going to talk about the AVENTAGE concept and how we built this. So we're going to cover 3 things pretty deeply: tonal balance, dynamics, and sound image. And then, of course, we'll talk about video because it has 7 HDMI 2.1 inputs, which is kind of the lead in the industry right now. And so these receivers will last you for a long time. I mean, that's one thing with receivers is they get the video systems pass them by. So you have a great Gene, your Z11. We were talking about the RZ11 from 2008. Yep. Still one of the awesome sounding receivers, but it has HDMI
1.4 probably, right?
3 maybe. I don't know. It was a very early on. So it's useless in an AV system.
Yeah.
There's nothing to plug into it. So this video platform is as far as we could possibly stretch it into the future. We'll touch base on that.
So to reiterate again, you're telling us that all the inputs are HDMI 2.1 right now out of the box.
Yes, not all the features are there yet. I'll get to that.
Yeah. Okay. I'm sorry. I get ahead of myself.
Yeah, it's a firmware update. The hardware is phenomenal. It's rock solid and it's in there. I'm running the beta version of it right now for Cedia because I'm doing the prep for the show, and we're running 8K video through a gaming PC, 4K 120 through a PS5 and an Xbox. So it does everything. It's working great, and it's all seven inputs, and you got 3 outputs. You got 2 that mirror each other, and then you got your zone output as well. So you can have, actually, one of our demos is 8K to zone 2, which,
oh wow,
who would have thought of that? I don't know.
Really.
Yeah. Okay, let's go through this real quick. So about it, like I said, every 10 years we kind of revamp the line, and change out the platform. AVENTAGE came out in 2010, which we touched base on that. So now it's time for a new look. We did a high-res display. Go online if you want to check this out. I don't want to get in all the details in this because I'm going to show you some of the stuff. A very aggressive-looking top cover. It is simplified. We don't have the 2 knobs in the drop-down door, which is pretty typical of the high-end receivers. The display, again, is a high-res display. When you change a function, it fills up that whole screen so you can read it farther.
Also, you can see it from 15, 20 feet away, right? Unlike
it's actually more readable. We were a little bit nervous when we saw the first early prototypes. Wow, that doesn't look very big. But the way it's designed, so when something changes, boom, it blows it up. You hit info, whatever you want, it blows it up, and then it tames it back down so it's out of your way.
So one thing I noticed that you guys still don't do is you don't have an HDMI input on the front panel.
No, we dropped that, and I think we always try to do features that a normal customer is going to use, not something that you want and I want. I want it. I want one in the front because I'm testing so much stuff.
Yeah, you plug REW and you do your measurements. It's just,
yeah, so I'm always standing on my head to reach around the back. So, and it took me a lot of years to get over that because you and I use things differently than someone that buys this, puts it in a home theater. Of course, you know, a lot of us online right now are hobbyists and, you know, and would appreciate that, but we kind of have to go for, you know, the 80-20 rule. So,
right.
Kind of thing. So AVENTAGE, massive transformers, rugged construction of the chassis, no vibrations. We'll talk about the processing, and then we got a bonus 2-year warranty.
I'm just happy you still have the 5th foot.
Oh, we're going to talk about the 5th foot, Gene, because I know I'm saving that to the end because I don't want you to leave early because this will keep you on the edge of your seat.
Oh, okay.
And I have proof that you were going to be a believer.
I can't wait to see that. You know, I love that.
We change platforms. That's why I said that about every 10 years, we change platforms and we rewrite all the code to last us in the future. We went from the chipset that we've been using for the last 20 years, we've been using the previous chipset, you know, different iterations of it. But we moved over to Qualcomm, SoC, a system on a chip. This thing is unbelievably powerful. Roughly, this has about 7 times the processing capability of what we had in the 3080, which this is replacing. We're not using all of it right now because we don't have anything to put in there yet. But in the next 10 years, what's going to come out? I don't know. That's why I've been in this industry for so long, because right when you think you know everything, then you read a little article about someone developing something, and then 3 years later, it's in everyone's product.
Yeah,
we have to be ready for that. What makes this thing really cool for the future is it's FPGA, which is field programmable gate array. With most models of chips and control chips and processing chips, they have a structure. So they have you can look at a chart, and they have a block diagram. They got a flow chart of what's going on inside the chip. It's just a matter of you programming how you go in and out of the little blocks that are inside the chip. This is completely programmable from the outside. So let's say, because right now this is running, you know, up to 13 channels. I think we can process on this, 11 for sure. And then, you know, who knows what's coming out a little later. But what if there's a 25 channel thing comes popular in 5 years for home audio? Guess what we can do? We can reprogram this chip with firmware to move all the little blocks around and build little blocks inside the chip to do things that we want. So it's field programmable gate array. This is what NASA uses when they shoot stuff, you know, to the Mars rover, and a circuit breaks down.
Right.
And then they send some code up, and all of a sudden the thing starts working. Well, what they did is they reprogrammed the processor, and the way the thing processed, they put it in a different chip and, you know, reconfigured everything. So this is really exciting. That's why this line is, you know, this is going to last us a long time.
So you wouldn't be able to get more channels out of the receiver because you would obviously need more preamp outs. You would basically saying you could use this platform to develop a product.
Yeah, you know, this one's pretty much set. We have room for firmware and stuff like that. You know, we don't have the hardware, you know, speaker terminals and all that to support that.
Right.
But next generation, or the 2 generations from now, we can do something with it. And what that does for us is, yeah, it allows us as a manufacturer to be able to move up and, you know, add features and things like that. But what that does for the consumer is we're getting so much technology. Now, this is a $3,000 receiver, and it sounds like a lot of money. It is not. When you look at what goes into building this, it's just such a deal that the amount of technology that you're buying in an AV receiver is such a deal. So by amortizing that over a 7, 8, 10-year period, then the customer gets the benefit of, you know, that rock solid platform will last us forever. We don't have to reprogram everything, raise prices up 10% or whatever every 2 or 3 years, whatever it is. So it's good for manufacturers to do stuff like this. Um, excuse me. So there's three concepts to AVENTAGE, to true sound. This kind of cross Yamaha AV products. Tonal balance. So this is what we kind of start with when the engineers are doing stuff. And this sounds like kind of, I don't know, what's all this stuff? This kind of marketing. What's this got to do with engineering? These are the precepts that the engineers use when they're making decisions as they're putting hardware together. So when we're voicing these receivers, you throw all the electronics in, that's just the start of the game, because now you're tweaking with stuff, voicing stuff, getting imaging, getting dynamics. But when we know it's right is when we have tonal balance. And then that way you can hear all the instruments separately. The human voice and an oboe, and you can clearly hear every single note from two different instruments. Then it's dynamics. It has to be dynamic, because that's what music is. Music, that's one of the things of music, is dynamic. It's not monotone. And the way we get dynamics is not just getting tons of power, and making the woofers jump out of the box. We have to reproduce the silence too. And that is that's something that a lot of people overlook. It's the silence, the difference between silence and energy. That's your dynamic. So yeah, you can add more on the high end, but what are you adding to the bottom end? And that we get the electronics out of the way of the actual audio coming through. So if you're listening to vinyl and it's coming through, and the little minute details on that vinyl, we don't want to smother that with a little bit of electronic noise or lack of dynamics.
Yeah, so you're talking about just getting the noise floor really low on these receivers.
Yeah, and it's kind of, that's part of it. Of course, that's part of it. And we have to have high power. But you want to hear, it needs to be able to resolve super low sound. So I get signal noise real low, but if the electronics can't resolve that little minuscule piece of content on the vinyl, you don't get it. The electronics is not there, but the electronics isn't reproducing that real tiny thing that's right next to, zero sound. Does that kind of make sense?
Yeah, I got you.
Yeah, so it's being able to do that. So yeah, it is more than signal noise, but that is part of it. That's what we would normally look at, 20 years ago. Well, let's get the signal noise down and it's going to be good. Well, over the years, we found out it's more than just getting a quiet amplifier. We have to be able to resolve those little nuances. And then the sound image, we're going to spend some time on that, because we do a lot of things on this, and especially with multi-channel surround, there's a lot of things that we have to do to get the image where we want. When we're doing 714 and we're doing Oro 3D with overheads, man, there's a million opportunities just to screw things up.
So that's interesting that you just dropped the Oro 3D name. You're basically, your receivers have never supported Oro 3D until till this date. Yeah,
it's a firmware update it's like really close. Month, 6 weeks. I don't have an exact date. I was trying to check on that earlier where they're at with that, but it's virtually here right now. So
can we cross mix? So can I take a 5.1 Dolby Digital?
I'm reading different things on that, because Dolby has a kind of stopped everyone from using third-party mixers with.
We got Dolby that reverse though. We got that reverse last year.
Yeah. Okay, then yes, because the bullet point is in there. It does Dolby and DTS, and it'll upmix it from there.
Awesome.
Thank you for that, because I'm going, why am I seeing contradictory things? Okay, so my engineers are correct.
Yeah, I asked that because I really do enjoy the Oro 2D upmixer for 2-channel music. I think it really sounds good. Very comparable to the Dolby Surround upmixer when you turn the center spread feature on. That way you still have good stereo imaging. So it's really good to have 2 different upmixers for people that are 2-channel and want to hear all their speakers activate.
Yeah. Nope, that's good then. So yes. And as soon as we get the firmware, I'll read the instructions. Okay, I'm going to focus on tonal balance. Now, okay, we're talking about all the tonal balance. Well, what's that mean? Well, this is how we do it. noise reduction, and we're going to go through these bullet by bullet. So low impedes, multi-layer boards, and I'll try to go through some of the stuff quick, but some of it's pretty interesting, or is for me, and I hope for some of our viewers. First of all three models that we're going to talk about today, the top three models are symmetrical amplifier design. So half the amps are on the left, half are on the right. And the big, massive transformer is in the center, right above the 5th foot, Gene.
Oh, yeah. Gotta have it there.
And I'm going to show you, it's more than the 5th foot. We didn't just take a flimsy chassis and cram a foot underneath it and say, okay, that's good enough. I'm going to show you all the brackets and everything else that's been added to these AVENTAGE receivers. So, you know, the advantages of symmetrical. We do it in our high-end 2-channel stuff, all high-end stuff.
So guys that don't know this, Yamaha has some really unbelievable integrated amplifiers. I mean, it's like old school back in the 80s. I remember as a kid growing up in the 80s, I used to see the really nice integrated amps, never been able to afford them. Now you guys are taking that up beyond. Now you have incredible DAC systems in there. You got really beefy power supplies. If anybody is really into 2-channel, you really need to look at Yamaha because their integrated amps are just solid. Yeah,
the last 7 years, we kind of lost focus on 2-channel because of, to be honest, with surround sound. That's where all the business was. You know, compared to 2-channel, people were buying receiver. You'd sell 200 receivers for every one mid-priced integrated, and that's globally. That's not just here in the U.S. That was a global thing. We are an international company, so we have to look at things globally. So we kind of, to be honest, I guess we took our eye off the ball. We were putting out some mid-price stuff, but about 7 years ago, almost 8 years ago now, we decided to get back into 2-channel. I mean, we're Yamaha. We're the largest musical instrument manufacturer in the world. Yeah. I mean, we got to do it all. And the AS3200 that's on the left here, that's about $7,000 for a 2-channel, 100 watts per channel. But that is an hour-and-a-half story in itself. That piece is awesome. One of the things that we changed this time is for the audio boards and stuff, we made 4-layer circuit boards in there. Okay, well, what's the big deal about that? So you kind of see from the image right here, the green and the oranges, and then the bottom layer that you can't quite see are 4 layers. Normally in a circuit board, so you put a chip in there and a resistor and a capacitor, and you solder it to the top of the circuit board. Well, if that chip needs power, then what you would have is a little foil pattern running across the surface of the circuit board over to that chip, and then daisy chain to the next chip, then to the next chip, and then the next chip. So you got power and ground and signal all going all over the surface. And then you got digital and control and all that stuff all on the same circuit board surface. It was really, this is one of those things that get that tonal balance that really helped us out. So what we do is we energize 2 of the layers. One is ground, so it's a pure ground, it's a solid ground all the way across, and then we put the power for that circuit board on one of the other ones. Then on the top and the bottom, that's where we put the audio components, get soldered to that. If they need power, what we do is we just tap down into the 3rd level down there to the power and get power. And we need ground, we just tap that chip in there. So we're not running power foil patterns all over the circuit board. So this is huge. This is a big improvement. More expensive, significantly more expensive, but we're going to have this platform for a long time. So let's do what's best. We updated the DACs. You can see the 8 has dual ESS Pros, and I'm not going to get into that. The A4 has a single 32-bit. The transformers are huge. The A8, the transformer is just shy of 15 pounds. That's heavy. And that's just one component. That's not heat sinks or anything else. The capacitors that we use in these are custom built block filter capacitors. And they do a lot. I mean, this is how you get dynamics. This is how you get realism. That capacitor, we can charge it up with a massive transformer, but if it can't discharge fast enough into the circuitry, you lose the dynamics. We're using WEMA film capacitors made in Germany, and they're some of the best audio capacitors known that are used worldwide in real high-end stuff. And so whenever you see these little red things when you're looking inside the unit, that's one of those.
So did you guys go with an Ecore over a Toroid mostly because you didn't have the width to put around Toroid? It was
no
spacing issue.
No, a toroid is good in certain applications, like a power amplifier, right, where you're running a sine wave plus and minus, plus and minus, plus. So it's kind of like rotating around 0 volts. A toroid works perfect, and it's got tons of benefits. Where toroids fall down is if you have a lopsided load. And what I mean by that, say you have a ton of digital, video, and analog. That's all on the positive supply, positive 5 volts, positive 13 volts, positive 14 volts. What that does is it puts the air core closer to saturation. So you're losing the headroom of what the air core is capable of. We use toroids in all of our audio in the 2-channel, the high-end stuff, because there's not a big load, of digital and processing and video and all that stuff that's in the plus to, the 0 to plus 5 range, or the 0 to plus 13 or 17 volt range. So the Ecore does a better job with imbalanced loads. And that's always kind of with AV receiver, we've always gone with that. We've done toroids in the past, but like the digital section, that Z11, the 5 volt digital section in that, because that's when we're using all 5 volts for digital stuff. It was a 40 amp supply just to power the chips that were in that amplifier. So something like an A8, you probably have a good 20 amp supply of 5 volts, if not more, of the digital side. So that is a lot. But what we did is we had some some transformers custom made. If you can see from this graphic here, we have 2 separate windings because there's kind of 2 different load characteristics. One is the voltage, and that's for the preamps. That's for a lot of the some of the digital stuff in the video stuff, but and then for the high current stuff, let's say the output transformer or the output transistors that need high current, we separated those supplies from each other, the windings. So it's 2 separate windings. So now when a bass drum kicks in the amplifier, boom, the current gets dumped into the amplifier out to the speakers flawlessly, and it has way less interaction with the phono preamp that you're listening to. It's coming in through the phono preamp, and you're dealing with millivolts and microvolts. Putting a big, huge load on it like that can affect that. So we went ahead. There are custom transformers in here, compared to the traditional, like you see at the bottom, the 8
right
X80. Super large wire. We have 14 gauge wire all over the place, and for a 3-inch run, you wouldn't normally use 14 gauge wire. You can get by with a 20 gauge wire. I mean, because it's the length as well as it is the diameter. So if you have a real short run, you don't need as big a diameter. For speaker wires, which is a long run, you need a big diameter. That can help. So we got giant wire through there. The copper foil on the circuit boards is thickened. We analyzed all the circuits. Wherever there was a high current section, we goosed it up. We put a double thick foil patterns in that portion of the circuit board. In Gene, for the 5th foot, we even added a brass bushing in the A8.
Nice.
Okay, so that's total balance. That's some of that stuff. The rigid mechanical structure. So here's your different chassis. The A2 has been out for a while. That's kind of your basic 7.2 system, and it's nice. It's AVENTAGE. It's got a nice remote. It's got the 5-year warranty that you can get with it, and so on and so on. But it's not symmetrical amplifier design. It's more traditional. The amplifiers are all on a single line. Where the break in the line really comes in is the A4, because that's where you jump into the center. So I'm not going to get into this too much, but because I want to talk about this right here.
Wow, what's going on there?
Okay, so we have this massive transformer. It's 15 pounds. It's hanging in the middle of the unit, probably the farthest from the 4 feet in the corners as possible. Transformers hum. Transformers produce vibration. You know, the higher in transformers is less, but they vibrate. So in order to isolate that vibration as best we can from the audio circuits and the amplifiers, we mount this transformer to this little brown box, and it's a real rigid structured box, which is mounted to that green cross frame. When you hear H frame, that's one of the H's right there from the edges of the side, and that green, you know, that's your cross of your H. So we mount it to that. And then it's got a double bottom plate. So the same as your MX A5200, you got a big, thick, I think it's 0.8 millimeter bottom plate on there. Just add more mass, so it's even less susceptible to vibration. So that's how we mount the transformer. Well, we need to mount the amplifiers, which are mounted to the massive heat sinks. So what we did is those little purple standoffs is where we mount the amplifiers to. So they're isolated from the transformer. So instead of just bolting everything directly to the bottom of the chassis and, you know, hope for the best, we do the best we can to completely isolate it. Now it's all mechanical, it's stuck together, but it does huge isolation of vibration and mechanical resonances and things like that. The H frame, here's another H, and this is right on top. This crossbeam. Okay, it's a crossbeam. Why do you call it an H frame? H frame construction is kind of a standard. I mean, it's used in buildings and architecture and things like that for strength and stability. We've boned that thing up, and so it's a lot more rigid. And actually, I'll show you when we get to the camera. It really helps out, and I'll show you that on the camera.
Yeah, because a lot of the Atmos receivers these days, they run hot because they're still the same size as a 7-channel chassis, but now you have 9, 11, 13 amplifiers in that, and you got to dissipate that heat.
Yeah, there's a lot going on in there, and heat's going to be made. How do we get it out? This is one thing that actually, to be honest with you, this scared me when I first saw this. That top cover is plastic. And I go, wait a minute, that's not Yamaha. That's not how we do things. And we just saw the top cover. We didn't have the whole unit at that time. This is early on, this is a few years back. And they were choosing a design for that. If you look, the whole top of that thing is pretty much open for ventilation. So there's just huge area for air to come up. If we remove that top cover, look what we have underneath.
Oh, wow. That's pretty rigid there.
Yeah, this is actually twice as rigid as the U-shaped top cover that drops over the top typically. But we made it super thick so we could punch all those holes in it. And that doesn't look very nice as a top cover of a unit. It's functional. It lets all the hot air out and lets it breathe. But we have to dress it up a little bit, and that's where the ABS plastic cover comes on top to give it that cool, aggressive look. Now, Gene, here we go.
All right, the 5th foot.
Now, we did something for you. We moved the 5th foot forward. It's almost to the front edge of the top cover. So you can see it easier. You can be able to admire it without having to look underneath.
Right.
When we do these remakes, we do a lot of stuff. The center foot, that worked really well for us because that was the first time we used it 10 years ago. But if you look, you see that kind of red hot spot that's in there. So there's one area of the chassis, putting that foot there kind of focused all the resonance and deviation, mechanical deviation to that one little area. So overall, it was less, but there was one spot that was pretty high. So what we did is we experimented with a laser vibrometer and moved the foot around, changed materials, checked out different materials, and we came up with this solution here. So it's a little broader based, kind of almost double the broader base, but the amplitude is 1/10 of what we had before. So by experimenting, and then you take it off, and then you get big resonance. Now, we did this scientifically. this is a scanning laser vibrometer.
Yep.
These
They use those in loudspeakers to check resonances.
Oh yeah, yeah. We use this a ton when we build speaker cabinets. You know, we look, is the box, where's the bracing need to be in the box, and where's the chassis reinforcements need to go, and you know, we use this for all kinds of things, and we've been using it for years and years. And then, but by experimenting with this, moving foot placement, things like that, this is about $500,000, I think. The last price I got was $350,000, and that was like 8 years ago. So who knows what they cost now.
Hey, real quick, Phil, we have a super chat here from Jason. He's wondering when the RX-A 8A will be available for purchase. I know it's on your website as a released model, but is it shipping right now?
There is a boat in Long Beach Harbor out here in California that just unloaded a container. And I am getting my A8s for the show. I've been waiting like everyone else. For our display at CEDIA. They might have been delivered to me today. I haven't been in the warehouse today. So they are coming. They are going to be slow coming out of the gate. There's some logistics reasons for that. Like there's no containers to ship stuff from the other side of the ocean over to here, and things like that. So, but we are up and running. The production is going. It's going okay, not 100%, because once we build them, we don't necessarily have a place to put them. We had a little sub factory that actually makes our music stands for the music division. You know, just a little, you know, $30 music stand. He had to stop production because he had built so many music stands. He had no place to put them, so he had to call us out and say, "Hey, if you can't get these out of here, I got to shut the factory down because I have no place to put them." And that's across all industries. That's just a weird example of, you know, we're not out of the pandemic yet because the supply chain hasn't, you know, balanced itself out yet. And
crazy what's going on. I mean, it's amazing that you even released a whole new receiver line, with the fact that it's so hard to get chips, it's so hard to deal with shipping. People, I don't think people really understand the gravity of this, and it's, you know, I hope we get over this soon, because it's crazy.
And you know, so everyone shut down all their factories worldwide there for a while, and then demand started building up, and when they started opening up factories, they started producing stuff. And I'm talking refrigerators, can openers, blenders, you know, anything. It's all, tons of it's made in China and in other places in Asia. Then all of a sudden, when everything started to open up, they loaded up all the containers and shipped them to North America and other places around the world. Boom, everyone's got product. Well, they shipped so much of it initially that a lot of smaller companies didn't even have a place to put the stuff. So they might got 4 containers. Normally they get 1 a month, you know, spread out, but all of a sudden 4 of them show up. So now you have 1 container unloaded into the warehouse. So you got 3 containers sitting in their parking lot waiting for them to get warehouse room. What that means, when they sit in the parking lots, they don't get shipped back to Asia or Malaysia or anything like that to get reloaded again. So like all the empties are over here in North America and in Europe, and where all the manufacturing is, they don't have any containers. And so they're charging 4, 6, up to 10 times the normal rental for a container. It's crazy stuff.
Yeah. So back, you were talking about the amp design, how you have a patent pending circuit for better slew rate. I can tell you guys, I measured the 5200, which is an 11-channel amp, and on paper, it doesn't seem very impressive at 150 times 11. But I ran that amp in a 6,000 cubic foot room, powering all my speakers except for my front speakers, which are really a demanding speaker. And that amp sounded great. It not only did it sound a lot more than its power was able to produce, but it never got hot, never shut down. And now we went and we moved that amp and we started listening to it on some Focal speakers, the Canta N2s on a full system. That is one of the best 11-channel amps for its price and the fact that it doesn't get hot. So kudos to you guys on that. So if you're putting that kind of technology into your receivers, that's awesome.
Yeah. And that's where a lot of it is going. You know, and being a music company, we have to have the stuff sound good. I mean, and this is another thing that we look at. An AV receiver or any piece of electronics is going to make noise. Now, I don't care if you're listening to Bluetooth, you're streaming Pandora, or you're listening to vinyl. when you hit that button, you're making sound. Now, you might not be doing DTSX, you might not be doing Oro 3D, but every time you hit that button, so we have to balance where we put everything resource-wise, because every time that thing's on, there's some type of sound coming out. So the 2-channel has to sound good, the 11-channel has to sound good, before we even start adding processing and you know, all the cool stuff that, you know, gets most of the buzz. But for Yamaha, especially with our heritage, the sound has to be good first, and we take a lot of pride in that.
Mm-hmm.
These heat sinks are really cool. On the left, it's kind of a small one. That's the best picture I could find. But that's a standard kind of slab type heat sink. It's a flat plate with some fins on it, and they come in different sizes. And these are standard. So if you go to Heat Sinks R Us, they'll have a whole selection of these, and you say, okay, I want 1,000 of them because I'm going to build, you know, 100 receivers or something, and you can buy them. Yamaha went about it a little bit different. If you look at our heat sinks, since we have our amplifier mounted to it to keep it away from vibrations of other areas of the chassis, we have a custom extruded heat sink, and you see it's all the mass is. Let me go to the next slide. All the mass is down at the bottom, down in here. So it's, you know, even if it's, but then we have this cross brace underneath that goes all the way across. And this reinforces everything. So when we bolt this down to those two little purple stands that we saw earlier, we're bolting down something that is super rigid to that. And then that is what's mounted. The actual amplifiers are mounted to the heatsink itself. We have 5-legged transistors. A standard.
Oh, wow, I didn't even know that.
Yeah, this is a standard transistor is 3. You know, basic emitter collector. We have 5. A transistor, when it gets hot, it tends to conduct more easily. So you start playing something really loud, then 1 millivolt of input is supposed to give you, 10, 1 amp out. 1 millivolt in gives you 1 amp out, let's say. But when it gets really hot, you put 1 millivolt in, you might get 12 amps out. So it's non-linear, and their silicone is very susceptible to that. So what we do, the common practice is to put a little thermal sensing device, and on the lower left, if you look at that little yellow block that's underneath the heatsink there, it's kind of hard to see.
Yeah, I'll zoom in. Yeah,
that little yellow block is a thermistor, and it's everyone uses it because you have to counteract the thermal runaway and get lower distortion. If we see how hot it is, and we can adjust the electronics and the feedback, and we can keep everything under control. The problem is when we do it the traditional way, the transistor gets hot. Let's say it's 200 degrees centigrade inside on the very surface of the chip of silicon. That gets hot. That has to get transferred over the heat sink. Then the heat has to transfer down to where that little thermal sensing device is. Well, there's a big lag in that. So if you have a really loud passage, the transistor heats up, and before the amplifier can compensate for it, the signal might have gone down to a small signal now. So now you're chasing it. So what we did is we're using transistors that have the thermal sensor built in on the silicone itself. It's built right to the silicone, so we know instantly what the temperature is of that, and we can compensate instantaneously. So when there's that big bass drum kick, we can compensate until it gets back to a smaller thing. So we're not chasing stabilized thermal stability. We have thermal stability all the time.
Right.
And then, of course, AVENTAGE, all parts are chosen. We listen to every single part there is. So now that's kind of the construction and stuff like that. I know that's a lot of detail in there, and I hope some of the listeners you're tracking it and think it's kind of cool. We're going to talk a little bit about some digital processing. Now, this is sound imaging, and we're going to spend a little bit of time on this because we have some unique features that address this, that help our sound image. So this is our original DSP back in 1986, and all those little circles are different frequencies and different levels, and then how far away they are from the center. That's the delay for each one of the little signals. So when you're listening to a sound field, you know, when you walk into a room, just your footsteps, if you're blindfolded and you walk into a warehouse, a giant cement warehouse, just the sound of your footsteps, you'll be able to tell that you're in a big warehouse almost, you know, just from that sound field of reflections, reverberations, and all that. And then if I can walk you and lock you in a closet, you will know that you're in a real tight space. So that's what a sound field is. It's the air around you, or the content that's around you, not necessarily the direct sound of the music, but what's around you. So this is all nicely balanced. But what happens when our speakers aren't where we expected them to be? So if we look at just the back half of the room on the left-hand side, you see how the sound field is just nice and spaced out and everything's balanced and like that. But in the room, we don't know what people are playing and how they're playing it back. And this has come important with 7.1.4 and 7.1 systems. We're going to see next why this concept right here is important. So you see if the speakers aren't in the right place, the sound field gets messed up and gets squashed towards the front. You don't have that three-dimensional open sound. Yamaha's YPAO system allows us to recreate the sound field, the way we measure it, back to the original state. So you can see the original sound on the right, and if you look on the top little box, I'm sorry, this is the most complicated part of the presentation, and this is the last slide of this. But you see how we can spread out the sound field so it's not squished up towards the front. So you still have an air of openness and an inclusion into the sound field. So let's take a quick look on how we do that. So we have a bunch of different, our YPAO is our room calibration system. It's the little microphone deal.
Yeah, and then you have the boomerang. That's what you do with the
boomerang. That's your 3D. We're going to do that right now. So base level is, you know, just EQ. Then we have a thing called RS, reflected sound control. So if you have a boundary next to your speaker, when we measure the microphone, we're going to hear that short reflection, you know, a couple milliseconds, 2, 3, maybe 5 milliseconds. It's getting pretty far out there. And the sound gets to you in the wrong time. So it's not clear, it's not clean, it's not pristine. And this is all part of the getting, not just getting a super quiet amplifier or that high signal to noise ratio we talked about earlier, is being able to deliver the signal to the listener in a clear manner so you can hear the dynamics. We have multi-point, 8-point multi-point in all the AVENTAGE models. And Gene, you've done tons of videos on this, and
yep.
I don't want to get any more than that. Your listeners know this stuff. But some of the stuff that makes our YPAO special is YPAO is part of everything that we do. It's in all of our DSPs. So when we do the room calibration, it's so much more than just EQ. We're using that data in with our DSP processing, our volume, our dynamic range, our loudness contours. All that data is used in all other areas. So it's not just a pure EQ the room. It affects how your loudness control works, how the dynamic DSP works. It affects everything. So people say, well, why don't you just save the time and just go out and buy, you know, someone else's algorithm? Well, we can't, because we couldn't get it to work with our process.
So if somebody sets up YPAO and they do all the angle measurements that you're talking about, and they decide that they don't want the EQ, if you put the EQ on bypass, do you lose all this functionality that you're talking about with the dynamic?
No. The EQ is kind of separated out. It's the same data that generates all the stuff, but the EQ, the PEQ, you go in there and you can adjust that. You can bypass it, and you're still going to have this. Now, if you don't even want this, we have what's called a pure direct mode, which will get rid of all processing.
Right.
Which is usually kind of ugly.
What's the sampling rate? What's the sampling rate on YPAO? Because a lot of room EQ systems, they downsample to 48K.
Yeah, and I don't have the latest numbers on this one, It depends on how much processing you put into it. So if you have loudness control and dynamics, if you have all the switches turned on, so you're doing the most amount of processing, then it tends to scale down. Majority of our stuff is done at minimum 96. Like I'm saying, 90% of our stuff is done at 96, but there are cases where it can drop down to 48. But that's when you got everything turned on, and maxed out, and the processor's going. Now, I don't know, with our new processing chip that we have in there and all the horsepower it has, maybe we don't have that problem anymore, but that's a good question, though. One of the things we do when we do the microphone measurement, we do it in 64-bit resolution. And okay, why is 64-bit when I'm only listening to 24-bit music? Well, because we can inject problems into the signal by only measuring at 32 bits. And this sweep right here shows you that. It will generate a little bit of noise. It's very low. And the harmonics are very low, over 100 dB down, 120. But we're using D to A converters that are, a couple of them are 124, 128 dB in the Pro versions. Now it's in the audio range, so we have to be careful. So we do some super high processing levels. Okay, I'm going to go through this, and Gene, I see we're getting close to an hour into this.
Wow, yeah.
Let me get through this, and then I have, we can turn the cameras on. We can look at the inside.
Yeah, I think everybody wants to see the inside for sure.
Yeah. Let's do that. Let me go through this one section here with the YPAO. The angle, this is the boomerang and the little stand that comes with it. This is kind of unique to us. Not many people do this, like no one. Back in 94, someone realized, hey, that's when surround sound was just starting out. Hey, we need some standards. And so the ITU, International Telecommunications Union, based in France, decided with all these multi-channel, and everyone had their own scheme, we need to standardize this because we're into broadcast and multi-channel. We need to know what the studios, where they're supposed to put their speakers when they're mixing the stuff and things like that. So this was great. This was the first standard. Dolby, later on, kind of based, if you look at the ITUR and then the Dolby standard, which is probably the most commonly used, they're the same. They overlap. There's a little bit different variances on it, but they're basically, if you do one, you're in the range of the other. So that's good. So Dolby didn't go out and do their own thing. They took an international standard. And this is just the placement. You want 22 to 30 degrees in the front, 135, 90. So it's all right there. So why is this important? Well, if we go to a living room and all the speakers are in that place, they're all the right angle, the perfect angle for you, the way Dolby, the way your National Telecommunications Union recommends, then what you have is you will have a nice, even sound field in the horizontal plane. There's going to be no holes or anything like that. This is perfect. Unfortunately, a lot of us live in this world right here, where we have a window or a door or an opening or something like that, and the speaker goes way back there. So now we're not in the perfect placement. The receiver doesn't know that, so it just is pumping out sound all the way. So you end up with something like this. So you'll get an overload in the back or kind of an acoustic hole off to the side. Well, that messes up the sound field. This is the sound field of your living room. So what we do is with our YPAO, we can, by measuring everything out, we can restore a symmetrical sound field. We do that with this boomerang deal down here, and it will actually measure the angle the speakers are from the listening position and put that information into the DSP processor. Now, I want to be clear here. This doesn't change where the Dolby track gets put or where the DTS left rear gets put, because those guys have locked that system down. But with our DSP overlay with surround AI or artificial intelligence, we can put a symmetrical sound field over the top of you. Now, so the 3-position boomerang takes care of that. Overhead, we got the same thing. You know, the kind of recommend is 45 forward, 45 back. People don't have that. You know, you got lights and fans and whatever else in there, so things aren't right.
So the angle stuff only activates when you turn the AI on.
Yeah, the AI or any of the other DSP that we have. Now, what that does is that helps fill in the sound field. So even though the discrete track is skewed off to the back left, like we saw in that one image right there, we're not leaving a hole in the sound field, so it kind of fills that in. So it's more natural. So even though the discrete sound's a little bit tweaked to the back, you don't notice that because the rest of the room is balanced and the sound field's filled in. Does that kind of make sense?
Yeah.
It's a little bit weird thing to get your head around, but it works, and you know, and the surround AI is a good example of that.
So my experience with the surround AI with the 5200, I actually really did enjoy putting that on for movies. I really did feel like I got a better envelope of surround with it engaged, but I didn't like it for music. Is that the same case now? Is it really only recommended you use it for discrete movies like Atmos?
Yeah, it's for multi-channel movies is where it shines.
Right.
It's not quite the right thing for me. If you got multi-channel music, it can help. But
yeah, I'm talking about like 2-channel music. It didn't sound right.
No. Yeah, that will sound a little weird. This little post that comes, a little microphone stand comes with it. That gives us 3-dimensional. So you do 3 measurements on the horizontal, and that takes care of your horizontal plane. You do one more measurement on that vertical post right there, and then that will tell you what angle all your speakers are from the listening position. So now we can map the DSP overlay, and so you end up with something like this. So a nice symmetrical sound field with your discrete 7.1 surround, and it's a cool thing.
And this works for Oro, like it works for all the immersive surround, right? It works for DTSX.
Yeah, I don't know how the Oro, I don't know how we're going to overlay our DSP on the Oro.
Okay.
I haven't seen that yet. I'm assuming we will, but I don't know that. So I can't answer that. You know, we do it with Oli, we do it with DTSX, so it's kind of a thing. Hey, you want to jump in? Because my next topic is the low frequency mode. I don't know if you want to do that now.
Yeah, we do. I think we'll cover that, and then we could show you the products, because I think that is something important to cover. If you
okay. One of the things that we added is what's called the low frequency mode, and this is a little bit different thing. It's kind of a hobbyist
DIY.
You know, a lot of your audience, you know, this is what we do. We tinker with stuff. And this is what this is made for. It's not necessarily for Fred and Ethel just to hit the button and, you know, figure it out on their own, because they don't care anyway. But this is kind of a tool. Look at it more as a calibration tool.
Yeah.
So with our, when you do our calibration and you do multipoint and all that, then once you do all the measurements, then you go to the parametric EQ screen, and then you have some settings. So it took all that data, it did tons of calculations. And so you can either select flat, which usually doesn't sound very good, front, where it will match all the speakers, and it'll analyze your front main speakers and try to timbre match all your other speakers to the main. So if your front mains are awesome, you like the way they sound, and you want to use them in surround sound system, this will fix that up. And natural kind of has a little X curve type of thing to it. But we add this low frequency mode. And this takes care of the low end. The slide says 200 hertz is actually 250. So it's 15.6 up to 250 hertz.
It's awesome you even go below 20 hertz like that. That's pretty hard to do.
Yeah, it is. But I'll show you how we do it. And I think I have some slides for you. So, okay, so we go snap, snap, snap. Okay, like we was asked. What happens when we do a snap? So every one of those snaps, this is what's happening. So we do the first snap. That's the tone you see in the left-hand corner. It's a little impulse, and it's a full frequency thing. It's pretty specially designed. You see this little blue H up there. this is the time window. So this is when we open up the microphone, capture the data, digitize it, and store it. And then we can come up with a frequency response. So we put the impulse in, and we can measure instantly a frequency response, just like you'd expect.
Mm-hmm.
Yeah, and then we, if you want, we can come in and correct it. We do that with the YPAO with the auto calibration. We'll do something with it. But this is why sound is just so amazing, because it's got more dimensions to it than what you can even comprehend. I've heard people try to explain it for years and years. I'm always hearing new stuff. Again, I've been doing it forever, and I get amazed all the time. So before we do the next snap tone, remember, so we had the little blue thing, so we took the blue measurement. We wait a little bit, and then we turn on the microphone again and take a second measurement from that original snap, that little ping test tone. Okay, so now we end up with something that looks like this green line over here, which makes sense because a few milliseconds later, the sound is going to decay, and so it's not going to be as loud. So, but let's just store this away a little bit for right now. And then we do it a third time. That's even farther down. We wait a little bit longer before we take that one. So the first one's already been done measurement. So we measure what's basically this last measurement is what's left in the room, what's going on. See, the high frequencies are completely rolled off, which is what you'd expect. So if we overlay these on top of each other, if you look at the right-hand side, the high frequency where the purple arrows are, the original one, and then a few milliseconds later, the sound, it dropped down 20 dB. That's just the high frequencies naturally decaying in the room, and then they just continue to drop down, depending on how dead your room is or anything like that. But when you overlay these on top of each other, look what's happening down here at 220 and 110. These are not decaying.
Yeah.
Yeah, it's dropping 5 dB while the high frequencies are dropping 30, 40 dB. Mm-hmm. So what we've done, this is a very clever way of coming up. This is where your room problem is. And, you might have several different zones right there. So this is a way we can actually do a pretty good job of identifying your room resonances and where you have problems.
So this does this on the sweet spot, right? It does it on the first measurement you do with YPAO.
The
money seat measurement, basically.
Yeah, it comes off of that one, right? And then the multi-point just fills in more data around the sides for that. But this right here, now you make me think a little bit, Gene. But
it could be an average of all. Like if you do 8 measurements, it could be an average of all 8, right?
Yeah, I think it could be an average of all 8 because the others are averages of all 8 positions.
Okay.
So right front. So
what you're talking about though is it's taking one pulse and measuring it at 3 different times to determine what has the slowest decay rate,
right?
Which would be problems with standing waves in your room that you're trying to fix.
Most likely, yep. So now what we can do is we can focus, and then the YPAO will focus some of. Well, it doesn't focus it; it identifies it. I think is the more correct term. This is why this makes it a hobbyist thing and not a one-time set it and forget it type of deal. So in this example right here, it takes 4 bands for the subwoofer, for instance, it takes 4 bands of parametric EQ and puts them down on the subwoofer. Now, if you see that big weird frequency response I have, the receiver only calculated -1 dB gain at 4 different frequencies. Well, that doesn't make sense to me because that was 20 dB too high. Why are we only correcting at 1?
Yeah.
This is where it gets really difficult to do stuff. So this is where it's good to we identify it for you, and then we give you the tools to go in there and manually adjust this stuff. Now, you can go out and buy hardware to do this for you, but now you're talking serious money. This is built into an AV receiver, and it identifies it extremely accurately. So you can go in and you can drop, let's say we drop the gain 8 dB at 84 hertz, and we listen to it. And then we adjust the Q, the width of it, and see where we're at with that. If we do just like a quick automatic drop in EQ on there, you can do stuff musically that is not good.
Yeah.
You can measure a flat frequency response and you can get the thing ruler flat, but what's it sound like?
I ran into that recently in my room. I have huge standing wave around 25 hertz because I just have lots of subs. And I went and I flattened it out so it looked really flat. And then I heard it and had no dynamics. It didn't sound right. So I went back and I boosted it a little bit. So there is a natural rise. There's still a little bit of a bump.
Yeah.
But it sounds so much better than if I got it ruler flat. So there's definitely trial and error. The measurements matter, get you to a point, but you at the end of the day have to listen and make sure the correction you're doing is not killing your dynamics or just not sounding good.
Yeah. Anything you see that says how to calibrate your room, the last step, listen to it and then tweak it.
So what I'm understanding here is that the LFM mode, low frequency, if I'm saying it right?
Yeah, low frequency.
It tries to identify the room problems, the standing waves in the room. It gives you a suggestion on where you need to make your cuts or your boosts, usually cuts. Tells you the cue, tells you the frequency. It's up to you now to get a third-party measurement software like REW and a microphone, which is what we always preach here. Measure it yourself and then see if the bumps in your listening area correspond to these filters that they're giving you. And if they do, then do the cuts that you need. And if they don't, if they're close, they might be a few hertz off. You could adjust the frequency. You could adjust the cue, which is the width of correction. And you could go and enter it here. And the cool thing about this, Phil, one thing I really like about Yamaha receivers and most of your competitors don't have is the fact that you have the receiver editor app through the web. You type in the IP address of the receiver. You could go into the PEQ if your laptop or your computer is on the same network. You can manually enter these filter coefficients and do your correction right there.
Yes, you can. And that's this slide right here. We updated.
Got ahead of myself.
No, this is perfect since you bring it up. This is what we've always had in the past for the web setup. Well, this is you type in the IP address /setup. This is what we've had for quite a few years. We've never advertised this for consumers because look at it. Yeah, it's an engineering thing.
It's not pretty.
It's not pretty, but you go from top to bottom, you will hit all 2,300 adjustment points in the receiver. So what we did, finally, since a lot of people are using that, we put a new skin on it. So now, nice. So now it's really cool. You can see everything that's going on. You can see what's going on in each one of the zones. You can do all your tweaks, your adjustments, your EQs, and all that stuff from here, which is way faster than going to the on-screen display.
Yeah.
And using the remote control.
So let me ask you kind of an obscure question. If I like what YPAO did full bandwidth, but it just messed up the bass, can I copy over its high frequency correction and then add this manual correction to that? Is there a way to do that?
You can't cross over the LFM and the high frequency stuff.
Okay.
It's either LFM or
so LFM
full band.
If I run LFM mode and I do my correction, it'll just do the bass correction for all the channels. You won't have all the high frequency correction, right?
Right. But you can write, since it's only 4 EQs, you can write it down and then you can go into the natural mode and adjust the
I see what you're saying. Yeah, that's cool.
Yeah, it's only 4, so that's pretty doable. It's not like 49 different. It's only on your subs that you're dealing with it.
Right.
Okay, I am losing some daylight here. I'm gonna stop sharing this. Yeah, I'm gonna see. Let's see if we still have some.
So the LFM, it only does that for the sub channel, or does it for all the channels?
It does it for all the channels.
Good. Okay.
And I don't know how they break up because the other channels have a 7-band EQ, and I don't know how many of those channels get dedicated to the low frequency. The subwoofer has 4 parametric. Yeah. So they get shoved down in there.
So how many parametric? So you're saying the whole, like a main channel has the 7 bands for the entire spectrum from 20 to 20K, right?
Right. Yeah, and people complain that our parametric isn't parametric enough. I think, and I agree. And so did our engineers. So we goosed it up. I think it was 49. We have 49 frequencies between 15 hertz and 250 hertz. So it's going
in
like
the past, in the past, you couldn't manually enter the frequency you wanted to correct. You had to go through different
right.
bands. So now you're saying you have more options and more granularity, basically.
Yeah, you have 4 times the amount of resolution.
That's
Okay,
good.
I'm going to try it just in the interest of time. I'm going to see if I've got enough light in here right now. I might have to.
So you have an RXA 8A with you. Is that what we're looking at now?
I can explain this. So RX A8. So A8 is the generation and the level. So it's Aventage is the first A, 8 is the performance level. That second A is a generational thing.
Gotcha.
And so we've done that with a lot of models over the last couple of years, and it's really kind of, it's for SEO, for search engine optimization. Yep. Because if I change this to the 12B, then you will get no reviews. You know, you'll have to start from scratch. It might not even show up until Google starts picking up the 12 or whatever model that it is. So if we just change the next generation would be 8B, then 8C. You know, car companies don't change their model every year. They just put a different model year on the same model name. So
sure.
That's pretty cool. Okay, we're looking at the top cover of the A8. Don't do this at home. You'll avoid the warranty. So here is the big plastic thing, which we thought was just a model, but it's it. It's ABS plastic. It's heat resistant. It's made for heat. We saw that picture of the inside of the chassis.
Yeah.
And I'm going to unplug this right now.
That's a good idea.
Yeah, I was worried about the lightning you had it. You're going to have there.
Yep.
So this is.
So normally that would be all screwed down. You can't just pull the cover.
Yeah, there's a 2, 4, 12. You know, there's a dozen screws on that hold this down. This is part of the structure too. You can see it's got ribbing in it and stuff like that. That's part of that H frame. This is that top H frame right there that we're looking at. That just adds more reinforcement to it. And this is really thick. If you look, we do things like this little rubber thing you can kind of see down here. That's kind of a piece of like a dampening material, kind of like maybe a Dynamat or something like that would be a common name for that. You see that used all over the chassis. Here's the side panel. So it's just like kind of, it's a metal side panel. But look what we did.
Oh, wow. It doesn't resonate.
There's nothing in there.
Yeah.
The heat sinks down here. You see this little piece of rubber that's on the fins? All those fins, we need to have the surface area for all those fins. But
otherwise it would ring. It would make a ring sound.
Yep. It'd sound like some chimes. So here's our symmetrical amplifiers right here. Electronics are mounted to the outside, blocked away from the center mount transformer. So we're getting them even farther away from any possible noise that could be generated down here. This is the business end. This is the processing. This thing's heavy.
It was about almost 50 pounds, right?
Yeah, we're at 47 and a half, I think, something like that. So this top board is most of our processing. Back here, these blocks right here. Well, let me go. This board right here, that's that Qualcomm chip. That's that fuel programmable chip that's in there. We have a fan. This is kind of an emergency fan. So if something does get really hot, this will kick in and keep the processors, get some air circulating in there. This right here is our network card. So this does our Wi-Fi and our networking. Network here. Here's an antenna here. Another antenna over here for 5G. So, and that's got heat sinks on. One thing that you'll hear, if you're new to Yamaha and not experienced Yamaha, people that are experienced with Yamaha, they're reliable.
Oh, yeah.
They very seldom break. And one of that is our design philosophy. Let me get this up on edge. And oops, I don't want that. Okay.
So would you say this has a significantly bigger power supply than the 3080, for example?
Yes. Yeah. It's because there's 2 more channels of amplification. I can't give you the volt amp. I don't have that off the top of my head. Yes, it's a bigger supply. It's definitely a bigger supply.
Yeah, it looks bigger.
It's a heavier unit because I've been lifting it all day. So on the back, right on this back row,
oh wow, look at the heat sinks on that thing.
Yeah, these are the HDMI chips. These are the chips that do the 4K 120, 8K video on all 7 inputs. All
Damn.
7 of our inputs are 4K 120, 8K video, 40 gigabits per second ready. So we got to mount them. So I told you earlier that. Yeah, okay, that's a little better shot right there.
Oh, good. You still have the balanced outputs for 2-channel in and 2-channel out for the mains, right?
Right, for the XLRs, yes, for the mains right there. 8K to zone 2, up to 8K. So I'm telling you, this is not going to be obsolete in 3 years by the video people. You know, there's not going to be a new technology that this can't handle. It's got the bandwidth on all the inputs. Right now, we only have an Xbox and a PS5 or maybe a gaming PC that does 8K or the 4K 120. But who knows what Netflix is going to be doing, you know, in a few years and stuff like that. But when we talk about Yamaha reliability, I'll show you something. So these are underneath these little heat sinks right here. They're not little, they're actually pretty big. These are attached to the HDMI chips. These chips run super fast and they generate heat. Now it's not spec that they need a heat sink, but Yamaha has built that into their manufacturing protocol. Every Yamaha receiver for the last, since we've been doing HDMI, has had a heat sink on it. And you don't see that. These are expensive and they have to be mounted. It's a lot easier just to use the naked chip soldered to the board and let the board help dissipate the heat, and hope it stays within the operating parameters, long enough for the warranty to run out before there's any failure. This is so overbuilt. I'm telling you, the features and technologies that are in this, and then just the build quality of it. The giant heat sinks down here. We talk about the railings. So there's 2 rails right here on the side. This is picking up a 50 pound. There's no flex. There's nothing in this.
Yeah.
And it's made not to vibrate and not have any resonances. And it does a really good job of that. And again, this is going to be a 10-year platform for us. So
when you say 10-year, does that mean if in 9-10 years down the road, you'll still be doing firmware updates as needed for this product?
Well, not for this product, but for this family of product.
Okay.
Usually, this is a little bit weird year because of all of the HDMI stuff. One of the reasons why this doesn't do 8K and all the video processing out of the box, it's going to be a firmware update that I said is shortly. Is we were actually waiting for the testing protocol for some of those gaming features. The quick transfer rate, the AAL audio low latency feature, the things that are a part of the HDMI 2.1. There's no testing spec for it right now. And what some manufacturers do, they build it to the recipe, the HDMI, this is what the standard is, but there's nothing to test it against. And they build it and then they ship it out, which is cool. It's one way of doing it. And then hope you can fix it with software later on. Mm-hmm. So when the testing spec comes out, oh, we missed it just a little bit right here, then let's just hit it with some firmware and then that'll fix it up. Sometimes that works, sometimes it doesn't. The industry had an example of that earlier last year with lower models. We all know about that.
Right.
So Yamaha is really conservative. So we're waiting for the testing spec to do the final firmware on it. It's working right now. Again, I'm using the beta software for the show, so it's we're looking good with that.
So are you guys doing like a demo area at CEDIA with this receiver showcased?
Yeah, and it's a little bit weird this year because Indiana has a kind of guidelines. It's not really rules. They're a little bit loose. So we got a mask if you're not vaccinated, and you don't have to mask if you are vaccinated. but they want to kind of keep some somewhat social distancing protocol in there. So instead, when you go to Yamaha at a show, then you've seen our demo room. We have theater seats and all that. We always have one, really killer demo. That's a lot of fun. And then we'll show some other stuff that's around there, and people come to expect that. We just can't do seating side by side, for a 3-day show with people crowding in and crowding out, crowding in and crowding out. It's just not a good thing. So it's gonna be more of an open area. We have a room, and we'll show 4K 120 with PS5, Xbox. We have an 8K signal that goes out to zone 2 out through a gaming PC. And so we're going to do the best that we can with what we got going on. I think people overall are just going to be happy that Yamaha has stuff that's coming out finally. Because like we mentioned earlier, it's been almost 3 years since we introduced and started shipping the 3080. So
yeah, wow,
it's about time. We're excited for this.
So one thing I didn't hear you talk about, and I'm assuming it's still on this new platform, is support for MusicCast.
Yes, yeah. I didn't bring that. I knew we were going to run out of time, so I didn't want to bring that up. So yes, it is full MusicCast, so it runs off an app. The one thing with the MusicCast app that they added to it is a lot of that web, deeper control on the MusicCast app, because people are using the app for all your streaming and linking rooms and all that kind of good stuff, which I think people are aware of. But initially we tried to keep that MusicCast app really basic. We want a real simple user interface, so we didn't want to complicate it. We got a remote control with an on-screen display if you want complicated. That's where you go in and have fun. Us guys here, this is where we go and have fun. So we try to keep it pretty benign with just the basic adjustments. But this time we've added way more in depth. So from the MusicCast app, we can tab down to another level and get a lot of the adjustments and parameter tweaks and calibrations that we can do in the on-screen menu without having to go in the living room and turning on the TV. You can do it all from right there.
Right. So on MusicCast, you still have all the app support on that, like Tidal, Pandora, all that stuff.
Yeah, we keep adding stuff, and we keep adding the high resolution versions of other things. And
well, the thing I wanted to ask you is, I'm sure you're well aware of the fact that we now have Tidal Music and Apple Music supporting multi-channel Atmos. But it's difficult to get Atmos through those platforms unless you have the right hardware. So right now you have to have an Apple TV, or you have to have a Fire TV or a NVIDIA. Do you see any possibility, because this platform is FPGA, like you said, is there any possibility that you could upgrade the MusicCast app of Tidal and do the multi-channel music through that without having to use a separate box?
That becomes a challenge. I know that is challenging. A couple things. One is licensing for that, and two is hardware. It's pretty sophisticated compared to what we have on our MusicCast network card that's in there. The capabilities of it. I know we're looking at it, and we've looked at it. We talk about it. Everyone knows what's going on, and obviously we want to put as much on there as we possibly can. And
it's pretty huge. I mean, it blew up in the last 2 months. I just can't believe how there's more and more Atmos music on these platforms now, and it's incredible. I mean, I never thought we'd see the day we'd be streaming Atmos music, but here we are.
Yeah, it's fun.
So people are asking if there's any redesign coming soon on the 5200 processor.
Not soon. Not soon. Right now.
To a date.
That's easy because I don't have a date. I know it's not in the near future. We gotta get receivers going again. We kind of picked a strange time to change our platform, which is good. It helped us iron stuff out better and take our time with it somewhat. But we lost a year of high-end business, and people have lost a year of enjoying flagship products, the cutting edge stuff.
Yeah.
So we're getting back on that.
So do you remember, people are asking about the prices, you know, from the RX2A all the way to the 8A. Do you know the pricing, availability, that kind of stuff?
2A is $899. I'm going off my head. I have a slide for this, but $899 for the 2A, $1299 for the 4A, and $23.99 for the 6, and $29.99 for the 8.
Now the 6 actually has 11 channels of processing, right? So if even though it only has 9 channels of amplification in it, I could go and add a 2-channel amp.
Exactly. Yeah, and for Aura 3D, the 8 can do 7 horizontal and 4 overheads, up above of that second layer. The 6, since it only has 9 channels, it do 7 horizontal. It can power 2 overheads, and we can add an extra amp or reconfigure the amps to do the mains and power that. So we can do 11 channel process.
So can I move the amps from the mains to an Atmos speaker and then use a 2-channel amp for the main output?
There's some flexibility in there. I'm not sure we can move the mains that you say that right now.
Okay.
Well, for one, I have not seen an Oro software come through yet on this, so I'm waiting for the firmware, which it's more weeks than months, so it's not going to be very much longer. We'll have that pretty quick.
Right. Well, cool. So just so you guys know, I'm already getting a RX-A 6A. Probably at the end of the month, I'm going to be doing a full bench test on that. I'm going to be integrating that into the Audioholics smart home, into our bedroom system, which has a full Klipsch Heritage passive sound bar, Klipsch speakers in the ceiling, 2 JL Audio 8-inch in-ceiling subwoofers, 5.2.2 just for my bedroom. Why? Because we're Audioholics.
Yeah, that'll help you fall asleep at night. That's perfect.
You know what happens? I set all this stuff up, I put TV on, and when I go to bed, I fall asleep within the first 20 minutes of a 30-minute episode of whatever I'm watching. Yeah. But it sounds good while I fall asleep.
Yeah, no, that's what makes it fun.
Is there anything else you'd like to add about AVENTAGE that we may have
let me take a look. Yeah, I think we got most of the stuff. The video stuff we talked about. I think the key thing with the video, I didn't want this to be a video training, but is all 7 inputs and all 3 outputs are HDMI 2.1, with the 4K 120 and the 8K. So other than that, I think we covered it. I know we went pretty darn long, but I think we got, hopefully we got the stuff all your listeners want to hear about.
So just to reiterate what the new line is, it's a whole new platform. It's based on a 10-year product cycle of
roughly,
roughly that you're going to be doing. Big upgrades for video processing. Everything is fully HDMI 2.1. For the first time, Yamaha now has Aura 3D capability that's coming. The power supply, the amplifier sections have all been upgraded. In fact, I was looking at, for every price point you guys hit, you seem to have the heaviest receiver on the market.
Yes. That's funny. I've always said that, because sometimes you can build a product to the spec. So if you want the lowest distortion product on the market, you can do some manipulation with the electronics and get low distortion. Two things you can't do. One is you can't cheat signal to noise. So that noise floor, it has to be designable to get low noise floor. You can't mask that with a poorly built product. There's no way to cheat that test. And weight. There's no substitute for weight. If it's heavy for a reason.
It's heavy for a reason, yeah. So a couple of questions people have. Do you have a release date on the Aura 3D firmware?
No, I don't have it right now. I know it's close. I was trying to get the number for you. And as soon as it comes, it goes online. And so when your receiver's plugged into the network, it'll do the update. Yeah. So what about future support for DTS X Pro or IMAX Enhanced? Are you guys looking at that kind of stuff? Yes, we are looking at it. I know there's been conversations. That's one of the things about the Qualcomm chip is we're not filled up.
Right.
Maybe with the 3080, we would say no sense even having a conversation about it and researching it, because we can't do anything. We don't have horsepower in the chips that are there. But what we have, so now it's opened up. So I don't know if it's going to happen or not. We have to do some research. Is it worth the engineering investment for the payback? But the hardware is definitely capable of that. So if we get the green light and move some resources over there, it's Yamaha is not always the very first into a new cutting edge technology, but we always try to be really good once we get there.
Yeah, and reliable. That's, I mean, the one thing about Yamaha, from my experience, is HDMI always works. That's a good thing.
Yeah, you got heat sinks on your seat. Pop the lid on that.
So some people are asking, are the receivers capable of driving 4 ohm loads? Here, there's a question here. I just want to say, what do you think about how your new generation can handle 4 ohm loads compared to what you've had in the past? Because I've driven 4 ohm speakers on the RX-Z11, the RX-Z7, those kind of things.
I have to be careful how I answer this, being a representative of the factory. It's not rated for 4 ohms. They're rated for 6 ohms. That's where they get the UL approval.
Yeah.
To get a 4 ohm rating, official 4 ohm rating, you don't just double the amount of power. It's the way the certification goes. It's almost like quadruple overbuild. With that said,
for heat dissipation.
Yeah, for heat in the transfer. With that said, Yamaha has always driven low impedance loads very well, and Yamahas typically are efficient design, so they run especially cool anyway. And it's the use application as well. I would look at if you're going to put it in a nightclub and try to run a dance floor into 4 ohm speakers. I wouldn't recommend that. That's not going to work. But if you're doing a movie at home, even stuff at home when it's cranked up is really not that loud for the whole duration. There'll be portions for short periods of time.
Right. So another question we have, which models have independent subwoofer outputs? I would imagine the 6A and the 8A do, but how far down does that go?
The 6 and the 8, and then the 4, I would have to look on that.
Sometimes those are parallel outputs.
Yeah. I know the 2 is a parallel out, so that they're tied together. The 4, I have not messed with the 4 yet, so I haven't seen the GUI on that. But I can. I'll check on that tomorrow.
Yeah, and I can put.
And then come to the show and we can talk about it.
Definitely, for sure. Well, Phil, I really appreciate you taking this time here, putting this live presentation together, getting us a RX-A 8A to look at up close. Seeing you pick it up by its frame was pretty awesome from the front of the frame. Yeah, that just shows you how well this thing is built. The last question I have for you, just thinking in the future, do you guys actually see a future for Yamaha receivers where you're going to switch over to Class D? Because Class D amps are getting really good now, but I know it is expensive to do a good Class D platform at the receiver level. What do you think about that in the near future?
When we can get it the way we like it, the way it sounds, so we can get that tonal balance, the dynamics and the sound imaging and all that. And we haven't found that yet to the level that we want. And we've experimented. Our pro side, we're digital all over the place. I mean, we're not novices to digital. We know digital. We built our own digital platforms as test platforms almost 20 years ago, 18 years
the
ago.
MX-1000, right?
No, it was actually after that. It was the MX-D1. It was a 1.5 rack unit, 500 watts per channel.
Yeah, I remember.
And we had to develop the chipsets for that because there was nothing off the shelf. And we got it pretty close to the way we would accept it and use it. It was more of a test bed thing. But we couldn't put it into a product. If you put it into a 5-channel receiver, then it would be a $12,000 5-channel receiver with 500 watts aside or per channel. So there's some stuff. You know how sophisticated music is, Gene. You're an engineer, and little things affect things. And we have a good recipe right now. We're not opposed to digital amps. It's just we can do a real good job with what is the platform that we have right now.
Right. So does your platform now, does it have like an eco mode where at low power it uses less power? And does it automatically switch over to high power mode when it needs to?
No, it stays in eco mode.
So in other words, if you don't use eco mode, if you want to have full rated power, basically,
Yes,
there's no auto. It's either eco on or eco off.
Yeah, because if it's auto, it's not eco. Yeah, that's just like leaving it off. So if your background music or TV watching something like that, and you're concerned about the power, throw it in eco mode. I mean, that works fine, and it only cuts the power in half, so it's only 3 dB or something like that for dynamic headroom. So it's still going to play loud, still going to do this, but for critical listening, like a lot of us are doing, yeah, let's just, if you're conscientious, just reach back and go in the menu and flip the switch when you're done with your listening. But no, it doesn't switch off.
Gotcha. Okay.
Sorry, that was a long answer to a simple question.
Yeah. No. Well, I appreciate all the info, guys. Don't forget to read the article that's linked in the description below. We have more details about these products. I'll be doing a full bench test report probably after CEDIA. I would imagine CEDIA is at the beginning of September, so probably shortly after CEDIA, we'll have some more information on that. I'll be doing a review of the RX-A 6A, which is 9 channels of amplification built in with 11 channels of processing.
Yeah.
So yeah, thanks again, Phil. Guys, don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to ask questions or suggest video topics. And I hope you guys found this useful. Please check the links down below. I'll put some links for the new AVENTAGE receivers that you guys can check out. Phil, again, thank you, my friend. Good to always catch up with you.
Yes, it is, Gene.
All right. And until next time, keep listening.